Okay, so hello everyone. For this discussion video, we have to have a little review of what is a pulse code modulation. And at the same time, we have to discuss the advantages and disadvantages of your PCM or your pulse code modulation. So before discussing the advantages and disadvantages of your PCM, it's necessary for us to understand what is pulse code modulation. So if we go back to concept of PCM or our digital modulation techniques, we have discussed your pulse code modulation as a digital form of your pulse modulation technique. This form of pulse modulation technique is known as your pulse code modulation, wherein pulse code modulation is a technique used to convert analog signals into digital signals. So and after converting the signal into its digital form, it becomes possible for us to transmit the digital signal through your digital communication network. And at the receiving end, it is converted back into its original analog form. So, pulse code modulation process involves the following three stages where we have discussed already. We have your sampling of the signal, we have your quantization of the signal, and coding of a signal. So, so we have now to discuss and consider what are the advantages and disadvantages of your pulse code modulation. So advantages of pulse code modulation includes the following. So we are aware of this that your digital signal, especially your digital communication techniques, have very high noise immunity. Okay, also, this is the very main reason why we have to transition from your analog communication techniques to your digital communication techniques. So in pulse code modulation, repeaters are used between the transmitter and the receiver. Repeaters are used to regenerate the received PCM signal. So the use of repeaters is possible due to the digital nature of the signal. And this is an advantage of your PCM. So effect of noise is further reduced due to the use of repeaters. Okay, because of the presence of repeaters in the process of transmission. So mas early pa naton ma-detect ang aton nga mga noise present sa aton nga signal because may mga repeater kita kag ma-regenerate naton ang correct signal before mag-retransmit liwat. So we have also, due to its digital nature, we can easily store PCM signals. Okay, this one is another consideration if we have to consider some storage of signals. So masapos store ang digital signals compared to your analog signal. That's why we have the process nga discuss natin in the previous mga discussion videos about analog to digital conversion because one of our reason is easy nga storage of your signals. One more advantage of using your pulse code modulation is the security of the signal. Okay, so take note that if we have to use your pulse code modulation, pwede kita makagamit various kind of coding techniques which we have to discuss later on so that only the desired person can decode the received signal. So, damo sang possible process in order for us to safeguard the safety sa aton nga ginatransmit nga data. And it can be achieved if we will be using your digital modulation techniques or specifically your pulse code modulation. Okay, on the contrary, we have your disadvantage of your pulse code modulation. So we have disadvantage of pulse code modulation. ECM requires large bandwidth. So as compared to other techniques, the encoding, decoding, and quantizing circuitry of PCM is um, quiet, complex. So, okay, so number one yung nga disadvantage, dako-dako ang bandwidth nga required kag compared sa iba nga techniques. And we have, so, ang iyang circuitry or ang circuit nga ginagamit for PCM is quite complex. And this is making it contribute to the disadvantage ng sining type of modulation. Okay, so I do hope medyo maplastar ni sa aton ang advantages and disadvantages of your PCM or pulse code modulation. Okay, so next, we have to discuss ang ginatawag natin nga mga digital modulation techniques. So last time, we have your mga palm PPM, yung mga discussion. Subong we have to discuss your digital modulation techniques. So ano ni siya? So in this discussion video or in this part of the lesson, we will discuss three kinds of digital modulation techniques. This includes your ASK or your amplitude shift keying, we have your frequency shift keying, and we have your phase shift keying. So first of all, let's go back to the concept of modulation. So ano ang modulation? So kung i-recall naton sa aton nga or your communication one nga discussion, when we talk about modulation, we have to consider that modulation is a process where some characteristics of the carrier or your carrier wave, whether that characteristic includes your amplitude, your frequency, your phase, ginavary siya naton in accordance with the instantaneous value sa aton nga modulating or sa aton nga message or baseband signal. So, based on the concept discussed, if ang aton nga amplitude sa carrier wave ang aton nga ginavary, then ginatawag na siya naton as your amplitude modulation. Kung frequency naman or phase of the carrier wave is varied according to the instantaneous value sa aton nga modulating signal, then it is known as your frequency modulation or phase modulation respectively. So, because or due to that concept, medyo masapos naton maintindihan subong ang ating nga digital modulation techniques. Let us understand the basic difference danay between your continuous wave modulation kag your digital modulation. So, na-discuss naton ang amplitude modulation, frequency modulation, your phase modulation, and tanan-tanan to under na siya sa category sa ginatawag naton nga continuous wave modulation. So, while your amplitude shift keying, frequency shift keying, phase shift keying, under na sila tanan in your digital wave modulation and digital modulation techniques. These are based on the nature of your message signal or your modulating signal. Ang kinalainan nila is your digital or your ang kinalainan nila I mean is your modulating signal. So sa continuous wave modulation, the message signal is of analog nature. But in digital modulation, the message signal is in digital nature. So we have here this one. It is in the form of your digital values. So in both of this modulation techniques, the carrier wave is um, of analog form. So, ang carrier wave naton is of analog form. Here it is interesting to note that the three forms of digital modulation techniques, whether that is ASK, FSK, or PSK, they are analogous to your AM, FM, kag PM. So, that's why hambal ko gani, medyo masapos na sa aton subong insyendihon. So, sige, so let us now discuss each digital modulation techniques. We have your ASK, FSK, and PSK in details. Okay, so we have here. So, amplitude shift keying. So, sa ASK, ang aton nga amplitude sa carrier wave get change or is-switch naton according sa aton nga digital input signal. So, this is your carrier wave. You have your digital input signal diri sa babaw. Therefore, amplitude shift keying is analogous to your analog modulation. So, or amplitude modulation sa analog modulation nga techniques. So, analogous siya or paris-pareho siya with your amplitude modulation. ASK is analog to AM because amplitude modulation sa sina nga type of technique, amplitude of the carrier wave is changed according to the instantaneous value of your modulating signal. Okay? In the same way, sa aton nga amplitude shift keying, Also, ang aton nga amplitude sa aton nga carrier wave ang gina-switch naton or gina-vary naton according sa aton nga instantaneous value. So, sa ang aton nga modulating signal or sa diri sa aton nga case, digital input nga signal. So, the difference sa aton nga nature of the modulating signal, amo lang na ang difference niya with your AM and your uh, ASK. So, in amplitude modulation, the modulating signal is of analog kind. But in digital modulation, it is a stream of your digital binary digits or your bits, digital bits. So now let us understand the concept of your ASK pagi sa sini nga figure or sa sini nga image. So we have here pasensya wala hindi continuous di ako nga part kay kabudlay sa hindi ko kabalo mag-adjust. But we have so take consider lang this is a continuous wave. Okay, so here in this image, kung makita ninyo, so this one, oh, wait. Okay, so ang ari nga mga values is as these are your digital input signal. Okay, this are our digital input signal. Syempre, this is our sinusoidal nga carrier wave. I know, carrier wave. This is your ASK. Okay, so ano ang kakakita naton sa sining nga image? Here in this figure, we observe that pwede natin i-observe ang behavior of your ASK. So we are going to modulate a sinusoidal carrier wave based on this one. So this one, ari siya sa babaw. So carrier wave naton is this one, your continuous nga sinusoidal, and then aton nga input signal is this one, your binary digits or your bits. So i-modulate naton ang aton nga sinusoidal carrier wave with your digital input nga signal nga 011 001. So amo ni ang gamiton naton nga digital input signal, amo ni aton nga sinusoidal carrier wave. So this image shows that your ASK waveform or your modulated signal. So now it's time to understand kung ano ang kakatabo or how this amplitude shift keying takes place. In the amplitude shift keying, we change the amplitude of your sinusoidal carrier wave according to the digital input signal, which is acting as your modulating signal or message signal sa sininga example. So the basic concept is we do not transmit the carrier wave when the digital input signal is zero. I-take note, kung zero dari wala ka dari output signal. Kung zero dari wala ka dari output signal. And transmit lang nato ang aton nga carrier or aton nga sinusoidal carrier if ang aton nga digital input signal is 1. So take note, may ara lang ta output kung 1 ang aton nga signal. So pwede nato ni observe as a sininga phenomenon or sininga phenomena sa sininga image carefully that in this example, we have digital input signal 0 sa tatlo ka places. So we have this one, tatlo ka place. So, are, nga kita tatlo ka 0. So for this 3 digital zeros, wala kita sang carrier signal nga gintransmit. But for binary values nga 1, at 3 places man. So we have 1, 1, 1. So may ara kita sang gin-transmit nga carrier signal. But for binary 1 at 3 places, full carrier wave has been transmitted. So without any change. So ang aton nga amplitude sinusoidal carrier wave is switched as per the digital input signal. So bot siningon may output ka kung 1 lang yung mga value. So the carrier wave is either not transmitted or transmitted. So based sa aton nga concept of your ASK. So but silingon when your output is 0, wala ka output. or where your input is 0, wala ka output. When your input is 1, may ara ka output. So either dugatong mo ka lang switch on and off. That is why your amplitude shift keying, ginatawag man siya nga your on-off keying. Okay, so take note lang. On-off keying. Okay, or your OOK. Okay, so that is for your amplitude shift keying. Now we will discuss your FSK or your frequency shift keying. Okay, so for your FSK, if ang aton nga frequency sa sinusoidal carrier wave is varied as per the digital input signal, then ang tawag sina is your FSK na. It is analogous to sa aton nga frequency modulation nga technique sa analog modulation. So the reason behind why FSK is analogous to your FM is sa aton nga frequency modulation, ang aton nga frequency sa aton carrier wave ginavary naton in accordance with the instantaneous value sa aton nga modulating signal. In the same way, sa aton naman nga frequency shift keying, ang aton nga frequency sa aton nga sinusoidal wave carrier ginavary siya naton or gina-switch siya naton as per the digital input signal. Ang kinalain ng nila, ang aton nga input signal sa aton nga FM is analog, sa aton naman nga FSK is digital. So now we have to understand some concept of your frequency shift keying, and we have to look at this image subong. So we have this one. So still the same, this is your digital input na signal. So digital input. This is your sinusoidal nga carrier. And this is our frequency shift keying signal. This is your FSK output. So this image or this representation shows three parts. May ara ta digital input signal nga 011001. May ara kita sinusoidal carrier wave kag may ara kita FSK nga waveform. So here, the basic purpose of your frequency shift keying is to modulate or change or switch sa aton nga frequency sa aton nga carrier wave according to your digital input signal. So now if we observe sa aton nga image diri, the three or the places where your digital input 0 is to be transmitted. Okay, so ari siya nga mga areas. Okay, so the frequency sa aton nga sinusoidal carrier wave is decreased. So, medyo naggamay ang aton nga frequency. So, that's why hindi siya amo naka-frequent mag-appear sa aton nga representation or sa aton nga figure. So, amo na lang niya ang aton nga representation, nag-decrease ang iyang frequency. And for the transmission naton or sa aton nga input signal nga 1, so medyo nagtaas ang aton nga frequency sa sini nga representation. So, in your frequency shift keying, we have two types of frequencies of the carrier wave. We have your low frequency for the transmission of 0, and we have your high frequency for the transmission of 1. In this way, sa aton nga frequency shift keying, the information of your digital input signal is present in the frequency variations of your carrier wave. Therefore, gakakita naton ang aton nga type or ang aton nga information sang digital input through sa aton nga dire kung nag high frequency siya or nag low frequency ang aton nga FSK signal. Okay, so take note nga ang aton nga information sa aton nga digital input signal gakakita naton sa frequency variation sa aton nga carrier wave. Amo na ang reason nga gintawag siya naton as your frequency shift keying. Next diri or last diri is your phase shift keying. So when we talk about phase shift keying, so phase of your carrier wave is varied as per the digital input signal. Phase shift keying is analogous to your phase modulation or analog phase modulation. So the phase shift keying is very much similar to your phase modulation or your PM. Because in both of these modulation techniques, ang ginavary naton is the phase sa ating carrier wave according to your instantaneous value of your modulating signal. The difference is that the difference only is that the nature of your modulating signal. So sa aton nga phase modulation, aton nga modulating signal is analog, but for phase shift keying, aton nga modulating signal is of digital nature. The carrier wave is of analog kind in both of this modulation, so wala man sa kinalain dira. Now we will have to understand the basic concept of your phase shift keying with the help ng sininga nga drawing. Okay, sa aton nga phase shift keying, the phase of your carrier wave is switched as per the input digital signal. This is analogous to your PM. Okay, so kung makita dari nato. So here in this image, makita naton nga ang aton digital input signal or sinusoid are together with your sinusoidal carrier wave, and we have also your PSK dari sa dalong. So same man Japan, this is your digital input, this is your sinusoidal, this is your PSK na nga signal. So now let us observe this image or this figure, this representation carefully. So this sinusoidal carrier wave is having constant amplitude. So constant ba ng iyang frequency, and also wala kita sang change sa aton nga phase. So diri sa aton nga sinusoidal carrier wave, constant aton amplitude, constant aton nga frequency, wala sang phase change. So you can observe here that phase of the sinusoidal carrier wave is changing accordingly to the digital input signal. So if we look at here, so the phase of the carrier wave changes only when there is a change in the binary symbol. It means that whenever ang aton nga binary digital input signal change is either from 0 to 1, then ang aton nga phase of the carrier wave changes by 180 degrees. So take note, kung um, if we started this way, so amo ni ang aton nga pag-start, for example, so sa aton nga signal, if we go in here, we will have your amo ni nga value. And then dapat tani ma-continue kita sa ating nga signal. But since we shifted from 0 to 1, diri, that means ma-shift ta by 180 degrees. Imbes diri ta dapat ma-start, diri ta ma-start sa babaw. So, and then we perform the same on Japon nga frequency and go on. If you inspect in here, wala nag-change ang aton nga frequency. Therefore, masigi-sige lang siya sa sininga nga frequency kay kag sa sini nga phase. And then paglambot niya diri, if you observe, may ara kita change of digital input. Therefore, from 1 to 0, nag-change kita. Nag-change kita value, therefore ma-change mo kita phase. So imbis diri siya dapat ma-continue, diri siya ma-start sa babaw. So this is your PSK. So 0, 0, that means wala sang phase shift nga matabo because wala sang may natabo nga change sa aton nga input signal. So continue lang siya up until may ara sang changes in the value sa aton nga input signal. So diri may change, therefore ma-shift kita by 180 degrees. So diri siya imbis diri siya ma-start, diri siya ma-start sa babaw. Okay? That is your phase shift keying. Okay, so pwede naton makita, we can understand diri nga ga-change kita by 180 degrees nga phase shift. So now medyo na-plaster na naton ang concept of your analog shift keying, your amplitude shift keying, your frequency shift keying, and your phase shift keying. Next natin nga discussion video, we have to consider isang damo nga types of your phase shift keying, and this includes your BPSK and your QPSK or quaternary phase shift keying. So this is it for now. Thank you. Stay safe. God bless.